Okay, all right. So today's lesson is basically going to be about indices and what and logarithms. However, we concentrate on indices today. When our indices is perfect, okay, then we go and look at what logarithm, because these two are strongly connected. That's why usually we treat them what together. Okay, so indices, you know, it's not new to you because it's something that you did in what in JHS. Am I right?
Yes, please.
The only
Yes,
difference
please.
here is that, okay, in SHS, you'll be given more complex situation, or will go deeper, okay, into it. So you will learn more. You add to your already acquired what knowledge. Okay, so that is what will be done. But our foundation will basically be on the rules, okay, of indices. And the rules, I know most of them, you are privy to them because, like I said, this is something that you did in JHS. So I expect the first section, okay, to be very interactive because you have a fair idea of whatever that I am going to say. All right. Now, indices, okay, we know, okay, is the plural form of what? What is the singular form of indices?
Index.
Index. Okay. So whatever we are going to do today, whenever you see index, okay, it means we are talking about power. Whenever you see indices, we'll be talking about what power. So usually in JHS, when you are giving, okay, an expression like this, maybe x to the power 6 over x was maybe squared. Okay, if you are not privy to the laws of indices, when I was introduced to math and we were given something of this sort, our teacher told us that this means x multiplying itself was 6 times. So I need to write this one as x times x times x times x times x. Okay, then times x. Let me count 1, 2, 3, 4, 5, 6. All over my denominator will also give me x times x. That is x multiplying itself twice. So if I want to reduce, then I start what? Canceling. Was that not what you were also told?
Yes, please.
Okay. However, okay, if your power is 100, does that mean I'm talking about if I have x to the power 100 or even 20 over maybe x, okay, to the power maybe 15? Does that mean the numerator, I'm going to write it as x multiplying itself 20 times, then the denominator x multiplying itself was 15 times before I start calculating? Okay, this is the crude way, the traditional way of dealing with, okay, the simplification of the situation that we have there. However, if you are introduced to or you know the rules of what of indices, you don't necessarily have to write, okay, whatever that you have here in the form that I just said. You can just use the rule to get your simplified word version. Okay, so that's all that we are going to do in our first section and probably maybe in our lesson for today. We'll be looking at what the rules of indices, okay, and how best to make use of what the rules whenever we are confronted with questions that require us to use those rules. Am I clear on that?
Yes, please.
Okay, very good. Fatima, where did you end? Okay, in which topic did you do coordinate geometry too?
Yes, please. We were on it.
You were on it. Okay,
Yes.
all right. Okay, as for Nancy, I won't ask her. She's through with coordinate geometry too, because I know. All right. So don't worry. Those other topics that maybe we were supposed to have done before coming to this, because I'm going by our school scheme of work. Okay, so those topics that you were supposed to have done before coming to this, that some of you have not done, I will see. If possibly, maybe, if I'm not able to create an extra day for us to look at those topics, maybe I will do a recorded version, then send it to you. of those lessons, send it to you to go through. If there is anything that you don't get, then maybe if I create an extra meeting, it will take maybe 31 hours, then you are fine. Is that clear?
Yes, please.
Yes,
Okay,
please.
very, very good. All right, so in view of this, we are going to straight away look at the rules of what? Of indices. Rules of indices. So rules of indices straight away. So rules of indices. Can you see what I have on the board clearly?
Yes, please.
Okay, very good. Okay, the first rule that we are going to talk about, so rule 1, okay, will be what we call the product rule. Okay, so with the product rule here, we are going to look at a number to a certain power multiplying another number to a certain power. So I'm looking at what? A number A to a certain power M multiplying the same number to a different what? Power. So let me use N. Okay, and please take note, whenever you have any, okay, number to a certain power. So if I have maybe A to the power M, you know that obviously we said this is the power, or which is the same as your index, okay, which is the same as your exponent. So we can use these three words interchangeably. However, what you have that you are raising to the power, the number that you are raising to the power is called our base. Are you with me?
Yes, please.
So a base to a particular power, a base, the same base to a particular power. And this will give us, okay, something that we've done in JHS. So please help me. Make your JHS teachers proud. Help me. I'm waiting.
A M plus N.
A to the power M plus N. So you add what? The exponent. So please take note. You add what? The exponent. Chiola is here. Chiola, are you here? It seems you are here. You are, yes. I have 2 Chiolas here. What is happening?
Please, I'm leaving one.
Okay, so leave one. All right. Okay, so that will be 8. That's the first rule. So for example, if I have 2 to the power M, 2 to the power 3 times 2 to the power 4. Okay, this will be equal to 2 to what power? So it's to the power 3 plus 4. So when you are multiplying, okay, same numbers, I'm talking about same base, okay, to different powers. Okay, you have to add what? Keep your common base or the same base and add what? The powers. So multiplication goes with the addition of what? Of the exponent. So this in effect will give us what? 2 to the power 7. Is that clear?
Yes.
Okay, very good. Okay, so it's not always that your exponent here will be different. It can be the same as well. Okay, only that when I use M and N, okay, I'm assuming that the exponent here is different from the exponent here. However, your M can be equal to what? N, because I can give you 2 squared times 2 squared as well. Once you have the same base to a certain power, multiplying, keep your base, then come and add the power. That's all, whether the powers are the same or they are different. Is my point well made?
Yes, please.
Very good. Okay, now the second rule is what we call the quotient rule. Okay, quotient or division rule. You can see product, okay, which give us what? The symbol multiplication. Now quotient will be, you have a numerator and a denominator. So that has to do with what? Division. So if I have a to the power m. This time around being divided by a to the power m, which I know is equally the same as what a to the power m all over a to the power m. So I can use this division symbol or division bar. They carry the same meaning. Is my point well made?
Yes, please.
Okay, so let me use all here. And this will be equal to, you keep your common base, which is a. Then this time around, when it is division, what do we do? It's something that we know. And I've told you, let's make it interactive because you know. Okay, so a to what power?
M minus N.
Very good. Your numerator power minus your denominator power. Okay, so in the same way, if I have example, if I have 3 squared, okay, let me use 3 to the power 6 divided by 3, okay, cube. Okay, this will be equal to 3. I keep my common base, and please, you can only do this when the bases are the same. So immediately the bases are different, you cannot use what we are using. Okay, that means we are not applying the rule that we have here, because for this rule, the bases must be the same. Only that there are powers that can be the same or can be different, the same. So in this case, what do we have? It will be our numerator power, which is 6, minus the denominator power, because this any number that comes after the division symbol becomes a denominator. So we'll get 3. So which in effect will give us what 3 was cube. Is my point well made?
Yes, please.
Okay, and we have the third one, which is what we call the power rule. Okay, so for the power rule, you will have what your number to a certain power, again raised to a power. Is my point well made?
Yes, please.
Okay, which we know will give us your base. Then what do we do here? It seems only Fatima is talking of. The rest of
M
you.
times N.
Okay, m, okay, times n. So mn. Very good. All right. Nancy, are you here? If you don't talk, you'll be a suspect. All right. Okay, so here, this is what we have. Okay, so example. Okay, if we have, okay, 3 to the power, let me say 6, all squared. We know that this will give us 3, then the exponent will multiply. So it will be 12 times 2, which is what? 12. So 3, okay, to the power 12. Okay, so let me just write, there shouldn't be any issue. Is my point well made?
Yes, please.
Okay, very good. We are not done with the rules. We have a whole lot of rules, okay, that we are supposed to consider. Then rule 4. Okay, if you have, okay, nth root of a, okay, this will be equal to, can you help me?
N into bracket A, N,
N into bracket,
A,
N into bracket, I'm writing it to N into bracket,
A,
A,
bracket close, exponential,
exponential.
Yes, please.
Okay. Any different answers? That's Nancy's answer. Hello, any different answers? Fatih, what will be your answer? Hello, Fatih, are you there? What will be your answer?
Yes, please. Mr. Akma, please, I'm not sure.
You are not sure. Okay, you
Yes,
tell me
please.
what you are not sure of, so that I will know what is in your head.
I think it will be into brackets
Mm-hmm. Mm-hmm.
n root of a and then close bracket half.
Okay. All right. Fiola, the last lady standing.
That one, please. I think it should
Mm-hmm.
be a raised to the power 1 on n.
1 on n. Okay, so I'm not going to conclude or pick the one that is right, okay, or the one that will be wrong. This is what we are going to do. I'm going to let us move from the known, okay, to the unknown. All right. When you have root of a, what will this be equal to? Okay, who just joined?
Starkman, please, Rosemary.
Hey. Mhm. You are very punctual, Papa. Okay, what happened? You were enjoying your sleep. Is it raining at your end?
Yes, please.
The weather didn't have Anyway, all right. So we are doing indices and we've gone through all the rules, and these rules are not okay. The three rules that we have here are the basic rules. Okay, so they are not new to you. You are familiar, or you should be familiar. Now we are looking at this one. Okay, so you agree with me that this is a to the power half. Do you agree?
Yes, please.
Okay, in actual fact, there is 2 here, but we usually don't write it. It's simply understood to be there. Any other number, okay, will be rated. So if it's 3, I'll write it. So this will be a to what power? 1 on 3. Do you agree? Hello, are you with
Yes.
me? Okay, especially Fatima and Nancy. Do you agree with me? These two
Yes,
that I have
please.
here. Okay, then if I force root of a, this will give me, okay, a to the power 1 over 4. Do you agree?
Yes, please.
So if I have nth root of a, you can see that if you look at study the pattern carefully, you see that all of them, you will get 1 over something. But that something becomes the index that we have here. Okay, when this is 2, the denominator is 2. When this is 3, the denominator is 3. When this is 4, the denominator is 4. So now that this is n, what will be the denominator?
1 over n.
No, the denominator.
N.
N. Okay, so I think you agree with me that this will be the best option to go for. Now, is that clear?
Yes, please.
Okay,
Yes,
so you should now know that anytime you have this, okay, anytime you have nth root of a, this will give us a to the power 1 over 1 over n. So if I have example, if I have, okay, first root of a, this will be equal to what? A to the power 1 over 1 over square. Okay, I've done the square root, I've done the cube root and the fourth root. So that's why I didn't use that one as the example. Is that clear?
Yes, please.
Okay, so you can see that with this one, your number that you were taking the nth root of had no power. In fact, it has a power, only that the power is 1, had no index. Okay, now I'm going to look at a situation where this a will have an index and you still have to take what? The nth root of it. What would that be? So 5, rule 5. If I have what? the nth root of a to the power m. Okay, let's see what will give us. That will give us. So this is going to give us, anytime you have nth root of something, so this should appear as an index. Okay, this will be your normal, okay, that you are taking the nth root of all to the power 1 over n. Do you agree?
Yes, please.
Yes, please.
Okay, very good. So at this point, now, this has become the power rule. So I can say that this will now be equal to a to the power what? M times 1 over n, which will give us m over n. Is that clear?
Yes,
Yes,
please.
please.
Okay, very good. Okay, so now let me see how many minutes left. Okay, so let's disconnect, come back. So let's give it an example for this one before we disconnect. So example, if I have the square root, or let me use the cube root of maybe 3 to what power? To the power 6. Okay, this will be equal to 3 to the power 6 or to the power 1 on 3. Do you agree?
Yes, please.
Okay, which in effect will give us what? 3 to the power 6 times. So this will cancel that 2. So I'm going to get 3 squared. So let me, for the purposes of explanation, I'm going to write this as 6 times 1 on 3. But you know that the exponent here can be reduced. So this will go here too. So I'll get 3 squared. However, as you mature this step, you can take it out. You can move from here to here straight away. This is only for explanation purposes. Is that clear?
Yes, please.
Okay, so let's disconnect and come back as soon as possible, okay, to continue with our rule. So now we have settled on or done what 5 rules so far. And remember, I told you we will have other rules that we are supposed to consider. All right, so quickly let's disconnect and come back and look at the other rules.